Okay, let's have a look at this question. Well, first maybe I'll write down a few answers that people came up with. Anybody like to offer an answer? No explanation, just numbers. Pauline? 6. Yes. 8. Any other proposals? 6 or 8. Okay, how many people said 6? A few. How many people said 8? Quite a few. Anybody say something different but you just didn't tell me? No? Okay. You still aren't telling me. Well, one of those is correct. Let's have a look. One way we could do this question would be to do what's called a tree diagram. Now, trees grow up, but when we do tree diagrams, often we have them grow to the side, just because it's more convenient. So here I'm going to have a tree diagram that goes to the side, where I consider each of the valves. So my first valve could either be up or down. And if my first valve is up, then my second valve, I also have a choice of up or down, or up or down. So the first valve could be up and the second valve up, or the first valve up, the second valve down. So here I'm kind of mapping out the different possible outcomes we could get. And then similarly, I'd continue. I could have up, 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 or up, up, down. And then we just keep kind of listing out those possibilities. And when we get to the end, we could have up, 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 or up, up, down, or up, down, up, which would be this path to there, or up, down, down. Anybody want to change their answer? No, you're all sticking with your numbers? Okay, fine. And then we have down, up, up, down, up, down, 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 up. Anybody want to change their answer yet? Way to be bold and brave. Thank you. Yeah, you know, there comes a point where we just have to swallow our pride and say, okay, maybe I was wrong. And then we learn, and then that's a good thing. Learning takes humility. There you go. Your word of wisdom for the day. And this last possibility, we could have down, down, down. And it could be that you may have just listed all these possibilities. The tree diagram is one way to do it, but you can imagine that suppose we had some instrument like a saxophone. How many keys or pads does a saxophone have? Anybody know? No saxophone players here? I don't know either. But you'd have a lot more possibilities that would come up, which would just take more time if we always used a tree diagram like this. So it looks like answer is not 6. The answer would be 8 different possibilities for how we could do this. Which leads us to the fundamental counting principle. But first, 8 possibilities. And what I'm doing is I'm just kind of adding up these possibilities. Now, let me point out to you that if I have all 3 valves up, is it possible that I can have 2 valves up and 1 valve down at the same time? So in other words, could these 2 outcomes happen at the same time? Yes or no? Anybody? I see some heads going this way. They can't both happen at the same time. So we would say they are mutually exclusive outcomes. In other words, if you have one outcome, it excludes the possibility of the other outcome happening. When we have mutually exclusive outcomes, we could say, well, I could have up, 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 or up, up, down, or up, down, up, or, and the word or is going to be a flag for us that tells us we're going to add. And we'll put this on a later page, but for now I'll just put here, or is going to mean add, particularly if we have mutually exclusive outcomes. In other words, if one happened, the other could not have happened. So if we can separate our outcomes like that, the word or is going to be a helpful word for us to keep in mind. But there's another word we could have thought of here, which is I have a valve position for my first valve, and I need to choose a valve position for my second valve. And I need to choose a valve position for my third valve. And is going to mean multiply, because I have two choices, and two choices, and two choices. And 2 times 2 times 2 gives me 8. That is the fundamental counting principle, which says if there are n objects in one set and n in a different set, then the number of ways of choosing one object from each set is m times n. And then there's the blank at the bottom. When choosing n objects from one set and n from another set, and means multiply. So often in math up till now we thought of and meaning addition. So again, it's going to be a situation where context matters. There will be times that and would mean addition, not very often in this chapter, but times in math. Most of the time in this chapter, and is going to mean we'll multiply. So, an example. We want to create a 3-digit number using these 6 digits, 0, 1, 2, 3, 4, 5. So we have 6 digits to choose from. And we have 3 different situations. So the first situation is we can repeat the digits. The second situation, digits can be repeated and the number has to be an odd number. And then finally, digit can be repeated and the number must be even. So if digits can be repeated, then what we can do is we can think of, well, a 3-digit number, I have 3 places to fill. I have my ones, my tens, my hundreds. And then I can think about how many choices do I have for each of those positions. This is ones, tens, hundreds place. Are there any restrictions on any of these 3 place value locations? Or can I use any of the digits in all of them? Yes. Pardon me? Yeah, we can't have 0 in the hundreds place because if I have 0, 1, 2, the number's 12. It's not a 3-digit number. So here, that hundreds place can't be 0. But I can use any of the others. So that gives me 5 choices. In my tens place, how many choices do I have? Call it out. 5, 6, because I can use the 0 now. And digits can be repeated, so whatever I used in my hundreds place, I can reuse. So yes, I have 6 choices. And then for my ones place, I also have 6 choices. So what's happening? I'm choosing a number for my hundreds place, and I'm choosing a number for my tens place, and I'm choosing a number for my ones place, and means multiply, and we get 180 different 3-digit numbers. Yes. Well, if I have something that's not 0 in front, suppose I pick the 1, I could do 100. We'd consider that a 3-digit number. So the 0 can be in either the tens or the ones place, just not in the hundreds place, in order to make it a 3-digit number. Any other questions with this one? Yes. We will come to an example like that. And then we'll look at how do we deal with it then. So we will have one of those today. As you look at this question, imagine we treated this kind of like chapter 3. So we did one lesson in chapter 8, and then we skipped on to another chapter, did another chapter this week, and then came back to chapter 8 next week. If you looked at this question, would you have any clue what you did? Maybe you would remember, but one of the challenges that's going to come up in this chapter is so much of our work is actually mental work in thinking through what the process is. So especially as we're working through examples in class, there'll be times that I'll pause and even times that I won't pause. What you should be doing is adding extra notes. What do you need to write down here so that you remember what was the thinking process for this question? So I'll give you a minute in case there's anything that you think would be helpful to add to your notes. Okay, let's go on to number 2. For number 2, digits can be repeated, but now we're told that the number must be an odd number. So, if the number's odd, how does that affect my choosing here? Yep. I have a restriction on the ones I can choose. So I can't use 0, could use 1, 3, or 5, so I have 3 choices for my ones place. Once again, I have limitations. So down here, let's just say this could be a 1, a 3, or a 5. So those are my choices. And then my hundreds place, again, because I want a 3-digit number, I need to keep in mind it can't be 0. So I'm going to have 5 choices for my hundreds place. But then I can use any of them, because repetition's allowed, any of the 6 in my tens place. So I'll choose my hundreds place, my tens, and my ones. Means multiply. So we'll multiply this out and get 90 possibilities. So, number 4. Why don't you try number 4? If you reason this question through similar to the previous ones, we would say, well, I want an even digit in my ones place, and I have 0, 2, or 4, so I have 3 choices. And again, I can't have the 0 in my hundreds place, so I have 5 choices, and then I have 6 choices, and means multiply, and we get 90, which we could have predicted anyhow, because we already knew there were going to be 180 3-digit numbers in total. If 90 of them were odd, well, I guess the rest have to be even, right? Because either it's an even number or it's an odd number. So suppose we come to number 5 and we say digits cannot be repeated. So again, I have a 3-digit number. typically what we want to do is we want to start with the choice that has the most restrictions on it, which is what I did for my first three questions. I just didn't highlight it. So when we did question 2, we started with the hundreds place because that had the most restrictions. We couldn't have 0. With question 3, we started with the ones place because that had the most restrictions. Then we went to the hundreds. Then we went to the tens number. If numbers is, as in questions like this, if the digits can be repeated, then the order we do them isn't a big deal. It becomes a bigger deal once we say that digits can't be repeated. So here, again, we have that restriction that my hundreds place can't be a 0. So if that's not a 0, then I have 5 choices. There are no restrictions on the others except that whatever I used here in my hundreds place, I can't use in my tens or ones place. So rather than having 6 digits to choose from, now I have 5. And now that I've used a digit in my hundreds place and in my ones place, now I have 4 digits left to choose from. So for example, if I list out those possibilities, the digits, and I looked at choosing for my hundreds place. Well, suppose I choose the 3. So then the 3 is gone. I can't use it anymore. So then I come to my tens place, and I can choose my 0, 1, 2, 4, or 5. I have 5 choices. So that's why we have a 5 here. But then I'm going to pick one. Suppose I do pick the 0 for that position. Now the 0 is gone. It's not in the runnings. I can't use it anymore. So now I have 1, 2, 4, or 5. I have 4 choices left for my ones place. So that's where these numbers are coming from. When we multiply this out, we'll get 100. So this is one where there may be some additional notes that would be worthwhile for you to add. So take a minute. How are you going to remember what our thought process was in working through that question? Next question, number 6. Again, 3-digit number. Digits cannot be repeated, and the number must be odd. So again, for a 3-digit number to be odd, the ones place has to be an odd number. So I have 3 choices there. And let me just build an example at the side as we go. And we got 0. So suppose I picked the 5 and I used that one already. Now when I come to my hundreds place, I can't use the 5, but I also can't use the 0. So now I'm down to 4 choices in my hundreds place. Suppose I picked the 1. Now I can use 0 for my tens place, so that option is back in the runnings, and I have 4 choices again for my tens place. I'm making a choice at each stage, and means multiply. So when we multiply it out, we get 48. Any questions? Well, I'm going to give you a couple minutes to try number 7, but number 7 is harder because the number can't be an even number. So that adds in an extra challenge because 0 is an even number. So we can't use it in the first place, but we can use it, well, I should say we can't use it in the hundreds place, but we can use it in the ones place. So see if you can come up with an answer for number 7. I'm not going to answer I'm not going to give you the details for how we could get number 7 just yet. First, I want to think about if there are 100 three-digit numbers where digits can't be repeated. And of those 100, 48 of them are odd. How many of them must be even? 52. Anybody get 52 as their answer? One person did. For the rest of us, we need to figure out how are we going to do that. So to help you move in that direction, let me look at number 6 in a different way. Let me imagine, instead of thinking it through the way I initially did, so what I did with this question initially was I started with the position that had the most restrictions, which was the ones place, and I made my selection. And then I went to the next most restrictions, which was the hundreds place, and then I ended up in my tens place. What if instead I thought about, well, 2 possibilities. That's a little big. Make that one a little smaller. There we go. So suppose I started with my hundreds place and I didn't think about my ones place. If I looked at my hundreds place, I could say, well, I have 5 choices for what to put in the hundreds place. But that causes a problem because suppose I selected 1 in my hundreds place. How many choices do I have left for my ones place? I have 2 choices. But suppose I picked 4 for my hundreds place. So I had 5 choices here, but I picked the 4. How many choices do I have here? Now I have 3. So we would say that these are not independent choices. And we have a problem because my choice here for the hundreds place is affecting what I can choose for my ones place, which is why the tip at the bottom of the page says, start with the position that has the most restrictions. But we could get around this because the problem is, did I choose an even number in my hundreds place or did I choose an odd number? So what I could do is I could say, let me get a smaller eraser, erase those. Suppose I pick an even number for my hundreds place. How many choices of even numbers do I have? There are 3, but I can't choose 0, right? So I only have 2. So I have 2 choices, because that first one has to be even. Then I'm going to have problems if I pick my tens place next. So now I'm going to go to my ones place and say, well, then I have 3 choices here. And if I picked 2 to the left of the digits already, now I'm down to 4 digits there. 2 times 4 is 8, times 3, 24. Or, keyword, or mutually exclusive option. So this is where we're coming to that question earlier about when do we have mutually exclusive situations. Here, if I force my hundreds digit to be even, it has to be distinct from if I force it to be odd. So these are mutually exclusive options. And if I start in my hundreds place again, how many odd numbers could I choose from? Any of the 3 odd numbers. But then if I go down to my ones place, how many choices do I have left for an odd number? I have 2 because I already used one of the odd numbers here. So I have 2 choices there. 2 of them are gone. I have 4 choices overall left. I'm choosing for my hundreds and for my ones and for my tens means we multiply. Again, I get 24. Or means I add 24 plus 24 gives me the 48 again. Could you use a variation of this to help you with number 7? Again, I'm going to give you some time. Okay, let's go through this question together. If we did it pretty much exactly like we did number 6, kind of the second way, I could say either I'm going to choose an even number in my hundreds place or an odd number. If I choose an even number in my hundreds place, how many choices do I have? Can't be 0, so it's either a 2 or a 4. So I have 2 choices. My last place has to be odd in order to make my 3-digit number an odd number. So I still have 3 odd numbers left. Yes? Oh yeah, I have to make an even number. Thank you. Yeah, that will be. Do I owe somebody a candy? From last week, in some class, I know I owe somebody a candy, but I can't remember which class. It was somebody from this area, though. Nice try, people over there. I kind of have the general area. Oh, well. Hopefully they remind me at some point. Yes, we're looking for even numbers. Oh, we want to keep the 2 there. Even and even. So yeah, if I had 2 choices here, I use one of them, but now I can choose 0. So I have 0 and one other even number, so I have 2 choices here. Of the 6 digits, 2 of them have been used. I have 4 choices left. I'm making a choice and a choice and a choice, and means we multiply. Or suppose I pick an odd number here. Then I have 3 choices, which means I have any of the 3 even numbers left for my ones place. I've used 2 of my 6 digits, and I have 4 left. 2 times 4 times 2 is 16. And then 3 times 4 times 3 is 36. 52 and 48 gives me 100. So I know I got the right answer this way. The problem with this one is, what would lead me to think this is how I should do it? So normally I wouldn't do the question this way. It works. I did it this way because we had that explanation from number 6. Instead, what I would do is I'd think of, what's my problem? My problem is that I need an even number, but if I use 0 in my ones place, I get an even number. But I can't use 0 in my hundreds place, so the problem is the 0. So more commonly what I would do for this, and again, there's more than one way to do it because we just did it a different way. The way I would think it through is I would say, well, what if I use 0, so I'm only looking at options where my ones place is a 0. Or, mutually exclusive, options where my ones place is not a 0. And then I separate my possibilities into these mutually exclusive outcomes. Or means I can add then. So, if I was to think it through like this, I'd say, if I use my 0 in the ones place, there's only one choice, because I'm using the 0. But now the 0 is gone. So I can use any of my other 5 digits for my hundreds place, and then any of the 4 for my tens place. And that's going to give me 20 when I multiply that out. If I look at my next possibility, if I'm not going to use 0 in my ones place, then I have two choices. I also know I can't use the 0 in my hundreds place, which leaves me with just one option there. Wait, I'm missing something. Oh yeah, because I can use the odd numbers. Huh, there we go. 4 options, because it can be anything except not 0 and not the even number that I used here. And then I have 4 choices for my tens place. When I multiply that out, that'll give me 32. 20 plus 32 does give me 52. So just given the question as it was worded, I would think this is a little more intuitive or makes a little more sense for me that, oh yeah, this is why I'm doing it this way, because I have this problem of 0. If my ones place is a 0, that affects how many choices I have for my hundreds place. If it's not a 0, it affects the number of choices that I have for my hundreds place. Challenging question. And again, you see how little we wrote down. And so is there anything you need to add in explanation here? I'll pause to give you a few minutes in case you need to add something. Next page has some check your understanding questions. And that finishes off our lesson, so you get lots of work time today. Very important, if I can have your attention. In every math class, you're always told that it's important to do practice questions. In this chapter, more than any other unit you've ever done in math, it's important for you to do as many questions as you can, because you'll see so much variety in the way questions are worded. With practice, you see similarities between the questions. But because pretty much everything is a word problem in this chapter, every word problem is slightly unique. The math that applies to it, there'll be a lot of similarities, but the more questions you do in practice, the more prepared you are for a new type of question that suddenly shows up on an assessment. So more than ever, practice as much as you can, find as many questions as you can. As we work through this chapter, we're going to stop and take a whole day just to do a whole bunch of extra practice questions. Okay? Because it's so important. So, having said that, here are 3 questions for you to try. Hopefully easier than the last question that you just did. Most of them are easier than the last question you did. Okay. Question number 8. Anybody have a question with it? 8 is good. Number 9, any questions? We're good. Now, for those of you who know biology and a little bit about genetics, you know that this isn't actually possible because there are some restrictions put in, as in you can't have all A's or something like that. But to make it mathematically reasonable for us for now, we just said, oh, there are no restrictions. Number 10. All of a sudden leaps to be much more difficult, as you may have noticed. I'm not going to give you the answer just yet. I will. But I'm going to tell you it's bigger than 100 and smaller than 1,000. So hopefully you're getting an answer in that range somewhere. Okay, let's look over the question together. Some of you are still diligently trying to figure it out, and some of you have just given up, it appears. And that's okay. This is an excellent example of a question where it seems almost impossible, unless you're going to take forever figuring it out, until you do a slight shift in how you're thinking, how you're viewing the question. And when we do that slight shift, you're going to look at it and say, oh yeah, that's not that hard. But the problem is we don't always see that shift, which is another reason why we want to practice as many questions as possible. So first of all, let me illustrate why this is a ridiculous question from one perspective. Because I can think about meat possibilities. I could choose meat 1, or meat 2, or both, or none. So that's not too bad so far. So I'm kind of thinking tree diagram, that's where we started. What's going to happen with the tree diagram? Well, then we start looking at, oh, let's do green for veggies. So I could do meat 1 and then veggie 1. And then I could keep going down the list until I get to veggie 6. But what if I do veggies 1 and 2? Or 1 and 3? Or 1 and 4? And then your brain starts blowing up. So we don't want to do it that way. Instead, what we want to do is we want to imagine, what are we getting here? A sub sandwich. You go to Subway. And you're at the counter and you stand in front of meat 1. How many choices do you have in front of meat 1? 2 choices. Yes or no. I want this meat or I don't want this meat. And then we move over to meat 2. How many choices do I have? 2 choices. Either I want it or I don't want it. And then we're going to continue down the line, veggie 1, 2, 3, 4, 5, 6. With every vegetable, we have the choice, yes or no, 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 yes or no. Which gives us 256. And you look at this and you say, oh yeah, that makes sense. But we have to be thinking this way in order to do it. So, but this gives us another strategy, right? You've seen it once. There will be a question that comes up in the homework, at least one, I think, that you need this type of thinking. So hopefully you'll recognize that again. And again, you won't see a ton of questions like this, but once you see a few, hopefully you'll come to a point where you can recognize. and say, oh, I can separate it into a subway type question, where I stand in front of my choice and say yes or no. Okay, so this is only day one. Hopefully you aren't too stressed about this chapter, but there are some questions that at first glance we don't always know what to do. And having written this out, how am I going to remember in a week from now, if I didn't do any more of these questions, what my thought process was? So again, add to your notes as you need to. So important in this chapter. What is the thinking that's happening that we don't see, that we're not writing down, but that's going to help you remember as you review these notes in the future? Okay, that is it for the lesson. We have about 11 minutes left in class. Good to practice a few if you have your workbook with you. And we'll say goodbye to everybody in online video land.